Lesson 4.4 Introduction to Complex Numbers. Our objective today is that students will be able to find the modulus of complex number and perform operations with complex number. So let's go into what is a complex number. So all numbers fall into a very broad category called complex numbers. Complex numbers can always be taught of a combination of a real number with an imaginary number. Remember earlier in the first lesson we talked about what is an imaginary number, a number that's in the form a plus b I, where a and b are real numbers and the I is the imaginary part of it. We say A is the real part and the BI is the imaginary part. This is similar to when we're plotting points. So when we're graphing complex number, we have to remember there are two components. They're the real component and the imaginary components. What I want you to do is just like graphing real numbers. So I want you to think of the real part, which is my A, as my X, and the imaginary is my Y. And these are in a two-dimensional system that we all know it looks like this, and it's called a complex plane. So in this, what I want you to do is that I want you to start thinking of this as we would graph this as 5 comma negative 2. This is my X, this is my Y. In this case, my 5 is the real and the 2I is the imaginary. So if I was to graph this, I will go 1, 2, 3, 4, 5, 2 down, which will be right here. This will be A. B would be 3, 1, 2, 3, and then 7 up would be right here. This is my B. C, remember, think of this as negative 2 comma 6 as you would graph a regular coordinate pair. Negative 2, 1, 2, positive 6 is 6 up would be right here. D is, and this is would be if you were graphing this as negative 4 comma negative 1. Remember that invisible 1 there, which is very important. So D would be 1, 2, 3, negative 4, negative 1, which will be this point right here. This is my D. 5I, so remember, the I is your imaginary. So in this case, we have 0, comma, 5. So this is my 0, 1, 2, 3, 4, 5 will be, how much as I go here? 1, 2, 3, 4, 5, right here. This will be my point E. Why is the 0 here? Because there is no real part. This is my imaginary part, which up here, remember, imaginary is your Y. And then the last one becomes negative 6 comma 0. This is my real, and then there's no imaginary. So at negative 6, which is all the way here, it's 0. This is my F. So think of graphing these points as just as it is graphing a coordinate pair. Now, the question, this is how it shows on the regions. If the complex number negative 3 plus 5I were plotted on a complex plane, which is just another word of saying this fancy looking plane, it would land in which of the following quadrants? So really quick, I want to review. This is your coordinate pair. This is quadrant 1, quadrant 2. Oh, that's not 2, that's 3. Let me take one of these out. Quadrant 2. Quadrant 3, and quadrant 4. You have to remember this, always go counterclockwise. So negative 3 plus 5I, if I was to write that, it's negative 3 comma 5. Where would that be? So let's make this red. Negative 3 would be 1, 2, 3, and 5 up would be 1, 2, 3, 4, 5, which would be right here in red. And that would be quadrant 2, which is choice number 2. There you go. Alright, so the modulus, all that big fancy word just means the size. So finding the size or modulus of a complex number, although it's not possible to say that one complex number is bigger than another, it's possible to compare sizes. So the size of modulus is calculated by saying that it's the absolute value of a plus b of I. Basically, what I want to do is my distance formula. The modulus just represents the distance the complex number lies from the origin. It's a Pythagorean theorem concept. So this is going to be my point right here. And I want to know the modulus. So the modulus is this piece right here. Oops, that doesn't look too nice. Wait, let's make that a little prettier. This is my complex number right here. And I want to know how much point is it away from my origin. I can make a right triangle and do this. So the shortcut is that I take the square root of the numbers and work it out. So let's look at the first example. It says find the size of each of the following complex numbers. Simplify your answer. So I gotta know what's my A and what's my B. So my A is 3 and my B is -4. I want to use this formula right up here and find the modulus or the size. This becomes the square root of 3 square plus -4 square. This works out to be 9 plus 16, which is the square root of 25, which is 5. So the modulus for this complex number, 3 minus 4i, is 5. That's it. What about this? My A is 12 and my B is 5. So I want to find the modulus. This becomes 12 square plus 5 square. 12 square is 144 and 5 square is 29. When I add these together, I get 169, and this will give me 13. That's the modulus, the size for 12 plus 5i. Now the last one, my A is -4 and my B is 2. So the modulus for this would be -4 square plus 2 square. This becomes 16 plus 4, which is the square root of 20. The question asked me to simplify, meaning I need to break this down. I know 20 can be broken down as to 4 times 5. 4 is a perfect square, so I give each of them their radical. Square root of 4 is 2, square root of 5, and this is the modulus for this here. One thing I want to point out is that notice that the modulus of a complex number is a real number. Remember, we talked about what's a real number and everything else, before. So the modulus, the size, is always going to be a real number, meaning it's going to be a number without the I. Now I want to take a look at some operations. Today we're only looking at addition and subtraction. Next lesson we're going to move into something a little bit more complex, multiplication and division. So the first thing, as always, when we were doing function lesson, always I want to do is keep everything in parentheses and distribute the negatives out. Get rid of parentheses. So the first two examples are 2 additions, and then we have 2 subtractions. So let's see here. I want to get, when it's addition, you remember this is the easy part of it. I can just rewrite this without the parentheses. Plus 6 plus 2i. And again, I want to group my like terms. So I know that -2 and 6 are like terms. And I know that plus 7i and plus 2i are like terms. So -2 plus 6 is 4, and 7i plus 2i is 9i. And that's my final answer. It's just like combining like terms. Remember, like terms have same exponents. So you just combine, look for your like terms and combine them. The addition and subtraction are the easy ones. So again, this is addition, so I can simply just go ahead and drop my parentheses and rewrite everything. Now look for my like terms. It's 8 and 12. And then my other like term is plus 4 and minus 1i. Remember that invisible one that's there, okay? So if I was to do 8 plus 12 is 20. And then what's positive 4i minus 1i is positive 3i. Just like combining like terms. Now with the subtraction, and this is where a lot of students make a little error, with the subtraction, you remember there is that invisible one that is right before the subtraction sign that you have to distribute over. So what happened is everything stays as is in the first parenthesis, so this becomes 5 plus 3i, and then I want to distribute this negative 1. So this becomes minus 2 plus 7i. Another way to look at it is that everything in the first parenthesis stays the same, and then in the second parentheses you switch the sign. So see how this was a positive 2 became minus, and then this was minus 7i, it becomes plus. Once you have this, we go ahead and look for our like terms, or 5 and minus 2. Remember, keep the sign with the term, and then of course we have a plus 3i and a plus 7i. 5 take away 2, we know is 3. 3i plus 7i is 10i, so your final answer is 3 plus 10i. One more answer to go. Remember, distribute this negative sign, that invisible one that's always here. This stays the same, minus 3 plus 5i, and then this becomes the opposite, so it's plus 8 minus 2i. My like terms are the minus 3 and the 8, so minus 3 plus 8 is 5, and then I have the plus 5i and minus 2, so 5i minus 2i will give me a plus 3i, and this becomes my final answer. So these are two simple operations, addition in A and B and subtraction in C and D. The only thing that's a little tricky is with the subtraction you have to distribute that negative sign. Our last example say, what is the sum of 6 plus 2i plus minus 8 minus 5i? What if the sum of these two were plotted on a complex plane, in what quadrant would this be? So first thing I need to do, this is a Regents question, is what's the sum of this? So rewrite, that's what I have, the sum of this. So rewrite, addition is easy. This becomes 6 plus 2i. Just rewrite everything without the brackets, plus negative 8 minus 5i. So my like terms are the 6 and the plus negative 8, and then the plus 2i and the minus 5. So when I combine this, what do I get? I get 6 plus negative 8 is minus 2, and then 2i minus 5i is minus 3i. So this is the sum. And remember, when you want to plot this, think of it as your first is your real and then your imaginary. So you want to make it into a pair. That will help you. So it becomes -2, comma, -3. That's the point that I want to plot. So this is my coordinate pair. I have a grid, just like you would, your positives, your negatives. So I want to plot -2, -3 would be somewhere here. And what quadrant is that? Remember, we talked about quadrant. This is 1, quadrant 2, quadrant 3, quadrant 4. So this actually fall into quadrant 3, which is choice number 3. All right, guys, I'm positive and I'm 100% sure that every one of you will get this lesson completed. Good luck. Remember to see me if you have any questions. Bye.